So as Arnold gave us the aspect of the macro and the micro and how these can actually work together, I'm looking at the aspects of how conservation can help energy efficiency and renewable resources, and how sometimes, although new technology is important, we sometimes forget the old technology, and that conservation actually can bring us back to new technology, old technologies, and help with new technologies. I'm giving two examples. One is a micro example. It's now a house which has been worked on in the past 5 years, and which we are monitoring as a system for not only conservation but also for energy efficiency and renewable sources. And the second is also a military site, has also a military connection, is the detention barracks, where we used the conservation management plan for the small unit to actually transpose to the big unit. And therefore the complex, how these will aid the grid, basically. One saying is, it is not important what the country can do for you, but what you can do for your country. I would say here in this case, since we're in a backed, what can you do for Europe in this case? The first system is a small area. It's a house. It was a military barracks for a period during the French blockade in Malta, and was used as a storage area for military arms during the insurgence of the Maltese with the British. Some examples. The conservation management plan as a methodology helps you understand the building, and we speak not only of the architecture of the building but also archaeology of the building today, and that actually gives you a step-by-step approach of how you actually discover your building again. And the analysis and the evaluation actually gives you the climatic, the microclimate of that building, and that is what I'm going to explain in these few slides. So we went with a regime for minimum intervention, keeping the carbon footprint to a minimum, conservation of the fabric as it is, the archaeology of the building and the respect of it, carbon footprint, minimum intervention, and minimum materials, and using natural materials as much as possible. Section of how buildings usually are composed in a local situation, double or triple window systems with fenestration, with louvers, which actually help the climatic conditions of a building, stone and lime-based systems, a section of a well there, a cistern, which every household has, and therefore storage of a resource, which is very important, and therefore you're not depending all the time on the grid and on government systems. So we had a phase one, which was the analysis, salvaging of material, microclimate, natural materials, and respecting the fabric and planning forward. Then you have the interventions, using natural materials and natural systems and discovering what the building is all about. And phase two is the adaptive reuse, and that is what is most important with military sites. What adaptive reuse you can maximize on the effects of your microclimate and how you actually adapt that building for the future. Some examples, those were ventilation shafts which were blocked up. Through the archaeology of building, we have discovered them, and these actually give ventilation, cross-ventilation to the whole building, making it the microclimate, making it more feasible to maintain as a building, because it stabilizes the atmosphere in the building, dilutes humidity, and prevents water percolation. Interventions, the design actually, with a superimposed structure, was not made to eliminate that circulation, but you can see ventilation systems through the steel and glass structure, which actually let the microclimate live its own system and not repress it. systems of lime wash, which actually conserve the building and actually go back to what the origins of lime washing was and how it can conserve your surfaces. The interventions. Minimum intervention with reversibility in mind, therefore this can be taken out and restored to its original. And then the new technology which aids the microclimate. So you have PVP panels through a scheme and the photovoltaic panels and the solar heating. And today, if you're interested, you can use solar power and win €2,000 if you're part of the club of European Citizens Climate Cup, which gives you an incentive to, as a citizen, to help out in actually helping the grid to be less intensely occupied by the citizens themselves. And you're actually helping out because you're giving back energy to the grid. How it works. So here you can see the section of the building. You see circulation from the cellar upwards through the center of the building, and this cross ventilation helps the atmosphere within the building through the old methods, through the old technology. You have then the new technology on the roof, where sunlight gives maximum energy to the house, to the unit, and back to the grid when it doesn't need it. Similarly, water resource, a very important resource, especially locally, but it's becoming everywhere an important resource, into the cistern, giving you possibility of using and reusing water during the whole year. So results. Through this experimentation process, we have found that we have maximum, when we have maximum sunlight, we're giving back 3 units per day back to the grid, which is 50% of the energy consumption in the unit. I think that is a very good way of being independent from the grid. And we have also 50% of water being used from the own resource, from your own resource, even during summertime. So the conservation of water during winter time, and I come from a climate where water is very, very scarce. You have 3 months of summer which is completely dry, but that gives you a consumption which is necessary for the whole of the 3 months. Similarly, we have adapted this process of conservation management planning to the barrack architecture, to a barrack block. It works in much the same level. We are investing in 50,000, for example, for restoration of a ventilation shaft. This ventilation shaft is above the cells of this main building. It needs restructuring, but it gives, because of sanitary law at the time, Victorian period, and this is a Roman concept as well, coming back from Roman times, it gives a very stable climatic condition to the building, and therefore you don't need you don't need technology for heating in winter, and you don't need air conditioning in summer, because it's a stable temperature. I will not be going into the maths of it, but basically, with one system, which we're going to have on the roofs with about 50 solar panels, PVPs, we're going to actually divide the consumption. We are going to actually save 50% from the grid, and we are having about 8,000 and over kilograms of CO conserved instead of actually emitting it. That's how the system works. On the top level, you have this ventilation shaft. You have a ventilation shaft with the double walls on the side. These are working. They always worked, but we were not conscious of it. Because of the analysis of the building, you have the system working. It helps with the technology. With the new technology, you maximize the effects. So you have the solar panels giving energy when it's needed into the prison. What is not needed, it goes back to the grid, and therefore you're aiding the whole system. You're helping the system, especially the industrial area around the project. And you also have big reservoirs which take water from the roofs, the big roofs, which now are being restored, and that water helps soft landscaping, grey water systems to be so that you can improve your system. I think that is my experience, and I hope that will help you think about it, and I think we can go for refreshments.